So welcome back guys. Now we'll do what is node analysis. Okay. So to explain the node analysis, I'm taking the same circuit which is explained in a mesh analysis, that is T circuit. So I'm taking this is 2 ohms, 3 ohms and 4 ohm. Okay. And I'm taking the source as 10 volts. Okay. So now the point is, what is nodal analysis? To do nodal analysis, we require Kirchhoff current law and Ohm's law, and we do nodal analysis to find node voltages. Okay, so nodal analysis is to find node voltages. Okay, now we will go to the circuit. What are the circuits we are having? How many nodes we are having? So what is a node means? When two elements are connected to, when two or more elements connected together, it is called node. It is node. Okay. So when two elements are connected, that is called a simple node. When two or more elements are connected, it is principal node. So here, if you know, when two elements are connected, this is a principal node, simple node. Let us say this is SN1 and this is principal node, that is I am keeping as SN1. And again this source and load in resistance, these three are connected to other principal node. Let us say P, I am representing principal and node 2. So totally we are one simple node and two principal node. So total nodes in this is 3 nodes. Okay. To do nodal analysis, we make one node as ground. So I am representing this circuit in this fashion. It is 4 ohms, this is 3 ohms and it is 2 ohms, and a source having like this voltage 10 volts. So I am making this node 3, that is as one principal node and one node as ground, and we rely on other nodes. Let us say this is this simple node as V1 and this node as V2. Okay, now what is node voltage? So many of you guys are not familiar with node voltage. So node voltage means it is not the voltage at this point, my friend. It is a voltage representing with respect to ground. That is the voltage which is observed across this branch. With respect to ground, the voltage across 10 volts is called V1. Okay. Now what is the voltage V2 means? With respect to ground, the potential, if we want to find a voltage across resistance R, means with respect to positive terminal and negative terminal, the voltage between that resistance is called VR. Similarly, if we assume the voltage across resistance R3, that is V3, will be equal to voltage across V4 will be equal to the node voltage V2. So V3 ohm and V3 ohm. This is about V2 means the voltage with respect to ground, the value which is across the 3 ohm and 4 ohm is called node voltage. That is the meaning of V1 and V2. Now the point is, to do node analysis we need KCL. So what is the voltage across V node at node? Voltage means, voltage V1 means with respect to ground already it is given, that is 10 volts. Okay, now at that point, now guys listen carefully. At node 2, so according to KCL, we need to assume that currents are leaving from that node. Okay, let us say at this node a current is leaving from this node. okay, and the current is leaving. So always assume currents are leaving. Ultimately, our aim is all currents are going to ground. That is law of conservation of charge, KCL. So what are the currents entering? Let us say this is I1, this is I2, and this is I3. So according to KCL, currents entering into the node, what any current is entering into the node? No. Equal to currents leaving are I1 plus I2 plus I3. So we are proving KCL, currents entering the node equal to currents leaving the node. So let us take again I1, same equation in this fashion. So what is I1 means? What is I1? I1 equal to, so if you want to find current means V equal to IR, I equal to what? V by R. So current is flowing at this branch. So current is flowing from this branch. What is the voltage of this branch is V2. So voltage I1 is V2 minus V1, the branch voltage. So the element branch voltage is V2 minus V1 by 2. That is voltage by resistance. That is I1. And plus at this is about I1. We got. What is I2? What is the voltage across 3 ohms? So current 3 ohms, through 3 ohms I2 is flowing. Therefore the current I3 is, in terms of Ohm's law, V2 by 3 plus current I3 is V2 by 4 equal to 0. Okay. So you work on this. How you solve this? So many people make mistakes here only. You just bring all V1s and V2s at one place. That is minus V1 by 2 and V2 into 1 by 2 plus 1 by 3 and 1 by 4. At this junction, don't do LCM here. Directly calculate this value in your numerator, in your calci, like this. Okay, 1 by 2 plus 1 by 3 plus 1 by 4. So you got the value of 0.1. So minus 1 by 2 is 0.5 V1 plus 1.083 V2 equal to 0. So from this is equation 1 from node 1 and this is equation 2 from node 2. Solving 1 and 2, you got V1 equal to 10 and V2 equal to. So how you will solve that V1 and V2? So go to equation 5 and in that in first one and use UDAS. So V1 1 you will keep, and for V2 here V2 is 0, so therefore we keep 0, and again we will keep 10 volts, and here V1 is minus 0.5 and V2 is 1.083 and other equal to 0. So we get V1 equal to 10 volts and V2 equal to 4.61 volts. That is a voltage across. What is the V2 value? Voltage across 3 volts. In before mesh analysis, we found voltage across V2 about 4.62 volts. The same value obtained by using nodal analysis. Okay, so that means for any circuit you can do both nodal analysis and mesh analysis. Only the response we need for whatever the method we use. If that method simplifies the things, means we will use that method only. And other method is, in this nodal analysis only also, one main thing I want to share here is, so this is for small circuits, this is method. If for a big circuit or if for a small circuit, you can follow this method only, which I am now saying. Okay, so the method is, in doing nodal analysis, always neglect simple nodes. That is when two elements are connected together, and make one principal node as a ground and rely on another principal node. Okay, So here how many simple nodes we have? 1 and 2 principal nodes, 1 and 2. So now what we'll do is we'll neglect this simple node and we'll make one principal node as a referent, and we'll rely on one other principal node. That means the circuit now I will draw like this. So I am neglecting this simple node. I don't need that simple node. I am making this another principal node as reference, and I need a voltage across this. That is I represent as V. So I am doing voltage node analysis at this node only. So this is 2 and this is 4 and 1. So now I assume the currents are flowing I1, I2, I3. Now the node equation at node 1, at node V, we have I1 means how we will draw? V minus, so if you flow from this here to here, always give the value of voltage value when the current is eliminating. So when the current is flowing, this I1 current is flowing out of minus terminal. So we need to keep minus 10 here. Minus ground voltage is 0 by 2 plus V by 3 plus V by 4. Now what is this? This is I1 current plus I2 current plus I3 current. So we are using KCL, but what we do is we just neglect the simple node. By neglecting the simple node, the I1 current we are getting is minus this V minus V minus 0. But here what you got? Only V2 minus V1. In spite of V1, here V1 equal to what? Again 10. So in spite of naming another, if you keep another node here, what happens here is 2 equations you are getting. So in spite of taking a simple node, another equation you will get. So if you eliminate that, this entire thing, what will happen? Only V is common. Now 1 by 2 plus 1 by 3 plus 1 by 4 will be equal to 10 by 5. So ultimately 10 by 2. So ultimately the value which occurred is 6.1 volts. Okay. So this is the voltage across 3. That's thing over. So the same value you will get. So if someone asks you to find what is I1 means, what you will do? I1 equal to V minus 10 by 2. And again I2 equal to V by 3. And again I3 equal to V by 4. This is about node analysis. In next class, I will solve one complicated circuit. In that circuit, I will do both mesh analysis and node analysis. Please follow and subscribe, and ask your friends also to subscribe and follow. Thank you guys.